This video is about graphing parabolas from general form, which is y equals ax squared plus bx plus c. The first step is to learn to rewrite from general form to vertex form. We've already been practicing how to graph from vertex form, so we just need to learn the procedure to change from general to vertex form. We're going to use a technique called completing the square. This is also reflected in your textbooks, so you can see that technique. The method that I'm going to show you is a little bit different that I use than what's in your textbook. Either is correct, so whatever that you want to learn to use is fine. Either will work. But I do use a little technique that's just a tad bit different. It may be different than something you've seen before. Our first example is y equals x squared plus 6x minus 8. Now, with this in general form, the first thing that you want to think of is to get the x squared and the x term by itself. In order to do that, we want to remove the constant value, and we're going to use a technique just like solving equations. So we're going to add 8 to both sides of the equal marks. So we get y plus 8 equals x squared plus 6x. So we've isolated the x terms on one side. Now, this next step is going to require us to think in our heads, but I'm just going to write these steps over here to the side that we are thinking in our heads. We are looking at the x term, and we're looking at the coefficient actually of the x. So we're going to take the 6, and we're going to take 1/2 of the 6, which gives us 3. And then we're going to take the 3, and we're going to square it. And that's going to give us 9. And we're going to take that value then and add it to both sides of the equation. So these are things that we're thinking in our head, but I'm writing them down for the steps on the side so that you will remember what we did. So we took the middle term, took half of that value, and then squared it. And then we took that value and we are now adding it to both sides of our equation. We're adding it to both sides because whatever you do to one side, you have to do to the other side. Now, notice on the left side, we do have some like terms, so we're going to combine those like terms. So that gives us y plus 17 equals x squared plus 6x plus 9. Now, as we look at the right side, we see that that is a trinomial, and that is in fact a perfect square trinomial. And so we're going to factor that. And remember, when we're factoring that, square root of x squared is x times x. The square root of 9 is 3 and 3. Because this middle term is positive, that is plus and plus in both sides. So we have two factors that are identical. So that means that we have x plus 3 squared. Now we made this a perfect square on purpose. That is what completing the square technique does, to make that a perfect square on purpose. The left side just comes down and follows along. Now we're going to undo the left side and get the y by itself. So we subtract 17 from both sides, and we end up with y equals x plus 3 squared minus 17. And now our equation is in vertex form. And since it's in vertex form, we can identify all those things that we have done before. What is the vertex? The vertex is -3, -17. The axis of symmetry is at the location of x equals -3. We know that the shifts of the graph, this graph will shift to the left 3 units, and it will shift down 17 units. So all of these things we can identify once we get that equation from general form to vertex form. So all of this helps us to identify those major things. So this is one of the reasons why we go from general form to vertex form. The one thing that makes general form easier is the y-intercept. The y-intercept is easier to see in general form because when we substitute 0 for the x's, the y-intercept is whatever that c value is. So it is easier to identify the y-intercept from general form. All right, let's do another example. So our example 2, a little bit more complicated this time. We have y equals 2x squared minus 8x minus 10. With this particular problem, you'll notice we have a value in front of the x squared term. So in that situation, we want to remove that value first. So since we are multiplying, we want to divide. So we divide everything by that value, which in this case is 2. So that leaves us with y divided by 2 equals x squared minus 4x minus 5. Then, just like we did in the example above, we want to remove the constant term, the c value. So we add 5 to both sides of the equal mark. So we have y divided by 2 plus 5 equals x squared minus 4x. And now we come over to the side and do our thinking. 1/2 of negative 4 equals negative 2. And then we square that. And so we get negative 2 squared is positive 4. And so we will add 4 to both sides. When we do that, our like terms will be y over 2 plus 9 equals x squared minus 4x plus 4. Now we're ready to factor our trinomial, which will be x minus 2 squared. It is minus because the middle term is negative. And then we have y divided by 2 plus 9. We're going to subtract our 9 across. And we have y divided by 2 equals x minus 2 squared minus 9. And then we multiply everything by 2. And so we have y equals 2 times x minus 2 squared minus 18. And so then as we talk about our vertex point, our vertex in this case is at the location 2, negative 18. Our axis of symmetry is at x equals 2. Our shifts would be, it would be shifting right 2 units and down 18 units. And also, because of this multiplying, it would be stretching up and going toward the x-axis. The y-axis. So, those are our identifying information about this particular general form, y equals 2x squared minus 8x minus 10. Let's do one more example. So this is example 3. We have y equals 3x squared plus 9x plus 6. In this particular example, again, we have a coefficient in front of the x squared. So the first thing we want to do is to divide everything by that coefficient. So we're dividing everything by 3. So we have y divided by 3 equals x squared plus 3x plus 2. We want to remove our constant term, so we subtract 2 from both sides. So we have y divided by 3 minus 2 equals x squared plus 3x. Now this gives us an example where that middle term is not a nice even number, but we're still going to come over here to the side and follow those same steps where we take the coefficient and we take half of it. And when we take half of it, we get a fraction, 3/2. We're going to take that and we're going to square it. And so 3 squared is going to be 9, and 2 squared is going to be 4. So we get a fraction when we do that. So we are adding 9/4 to each side. Now we need to think about common denominator. And for some of you, that's a little tough to remember. So let's do that over here on the side. We have 9/4 minus 2. Our common denominator is 4. So that term remains the same. So if our common denominator is 4, then 2 times 4 would be 8. And so 9 minus 8 means that we have y over 3 plus 1/4 equals x squared plus 3x plus 9/4. Now we're wanting to factor this trinomial. Now one little trick about this factoring is that this is going to be whatever this half term was. So this 3/2 makes that easy for us to remember. When we took half of this term, that is our factor here when we factor it. So we have y over 3 plus 1/4 on the left side. And now we're ready to subtract the 1/4 to each side. Y over 3 equals x plus 3/2 squared minus 1/4. Now we're going to multiply through everything by 3. And so we end up with y equals 3 times x plus 3/2 squared minus 3/4. And so this time when we talk about this particular graph, this graph will have its vertex at negative 3/2, negative 3/4. The axis of symmetry is at x equals negative 3/2. The shift of this graph will shift to the left 3/2. It will shift down negative 3/4. It will also have a stretch of 3 units up to the y-axis because of the 3 in front of the x plus 3/2. So again, this video is about changing from general form to vertex form. This gives us 3 examples to use using the technique completing the square.